Hey guys, welcome to ManCave. This is episode number 3 and I'm still troubleshooting the Tektronix 2201 oscilloscope. In the last episode we managed to get it running. We managed to get the power supply voltages up, however they were slightly out. You could also see that there was a signal on the screen, and I was playing with it since. Obviously we need to sort out the voltages. I bought the service manual, I had a look at it, so sorry about the mess here. That's all the service manual that's been printed out. We're gonna have a look now to see whether we can fix the excessive voltage on all the rails. I do suspect a few things. It could be the linear regulator, which is done by the LM358 dual op amp, or it can also be anything else. Now I'll show you the schematic of the service manual, and then we'll try and see whether we can find out what is gone possibly wrong. I have also been playing with this a little bit, and I managed to probably mess it up even more, because now I don't even get a trace on the screen. It seems like possibly the time-based board has blown up some of the components, and so well, I'll power it up and I'll show you what I mean. Right, so it's powered on now. If I press the beam find, you can see it's there, but it's just a dot. And I'll inject a 100 kHz signal into channel 1 AC couple. That trigger light comes on, so it seems to be triggering. We'll put the channel 1 on. You can see that the vertical works okay, but if I adjust the horizontal, it doesn't do anything. Well, it does do something, but not something you like. You can move the position, but it still doesn't do anything that you'd like it to do. Okay. Another thing I noticed is, let's move it in the center, is that when I press the storage mode, when I turn on the storage, it does something. Now, it's not very good either. It's not going to help as much. So you can see it's doing something, but it's not very good. So I possibly messed it up even more by running it with the higher voltage on the rails, but that's okay. We've got some more troubleshooting to do. So first we have to fix the voltages. If we manage that, then we'll have a look if we can fix the horizontal time-based board. A little challenge. Okay, I've removed the storage board to see whether that makes any difference. Probably won't. Let's see. Turn it on. Beam find. The horizontal board is probably faulty. I bought the service manual for the Tektronix 2201, and this one is for 2225, and the reason why I'm using the 2225 is much clearer, and 2201 has a lot of mistakes in it. So I'm gonna take you through the power supply circuit. I'll take it back a little bit. So this is the whole power supply circuit here. It starts here with the mains input transformer and the rectifier bridge, and then outputs to the pre-regulator, which consists of the TL594, which is what we swapped. However, we swapped the one in the inverter. That was the one that was faulty. So the TL594, according to the service manual, drops the input voltage, which is 57.6 volts, down to 38 volts. The 38 volts then goes through a series regulator. The series regulator, according to the service manual, the main function of it is to reject the ripple current which comes from the mains, because it's rectified. So you have for each wave, the positive and negative part of the sine wave are rectified. You get twice the mains frequency ripple current, and so the series regulator is made to smooth that out. So you have the initial regulation down to 38 volts. Then you have a regulator which takes out the ripple current, and then here you have the inverter section, which is basically an oscillator. What I didn't know before is that this TL594 is driven from the oscillator of the pre-regulator, so it doesn't actually have its own oscillator, and it drives these output transistors, which then in turn drive the output transformer. And on the secondary of the transformer, then you get your output voltages. So the main problem we have now is that the output voltages are too high, and also according to the service manual there should be a about 1.4 volt drop on the series bias transistor here in the series regulator. What I'm measuring is 0.83 volts. That's very little. So I suspected that it could be the regulator itself being faulty. Also, you can see here that this pot is to adjust the minus 8.6 rail, which then in turn adjusts all the rails. However, it doesn't do anything. So from that I suspected that the op-amp may be faulty. I replaced it. I didn't have a LM358 handy. Not a new one, not the one I would trust. I could take one out of an old board, but I didn't want to do that. Instead I took what was it, 1458 I think, and I stuck it in, and it didn't make any difference. I think it would work just the same. It's not a particularly high performance application, so it'll be fine. So that didn't solve the problem. I bought a new LM358 since, so I'm going to replace it back just in case. But what I suspected is, because on the output of the pre-regulator we're not getting the correct voltage, so I thought the pre-regulator could also be faulty, as well as the inverter circuit was. And so I bought the TL594s, and I'm going to swap both the inverter and the pre-regulator. I'm going to start with the pre-regulator first, because we have 494 in the inverter circuit, which I swapped in the previous video. So I'm going to try and swap this one now and see if that makes any difference at all. I posted this topic on the forum. David replied saying that if the 38 volt rail is correct, then the pre-regulator is probably okay. However, the 38 volt rail is not correct. I'm getting about 40 volts on there. So I do still think that the pre-regulator may well be faulty. So that'll be my first suspect, and I'm going to try and replace it. He also suggested that maybe the Sine diode in the reference circuit here for the op-amp may be open, or the series pass transistor may be shorted. I don't think that's the case, because we're getting a little drop on it, and I also measured it when it's off, and it was okay. I'm going to do it again on the camera now. I'm going to measure the transistor. I'm going to check the Sine voltage. I measured about 6 volts there, I think, and I'm going to measure the 38 volt rail, and then once we have the record of this, I'm going to go ahead and swap the TL594 in the pre-regulator. Okay, so we're back here with our fluke. I'll just touch the ground. And so I'm going to probe, first I'm going to probe the 38 volt rail, just to see whether we get any reasonable voltage on it. So that's the That's the one here. Let me just swap hands. So the 38 volt rail gives us 40.23 volts, 40.24, so that's definitely not okay. So that's the reason why I suspected the pre-regulator. So if you measure the zener diode, there's the VR931, as David suggested. It measures 6 volts. It's supposed to measure in 6.2, so that's not very good. But it's, you know, it's in a ballpark, so I don't suspect that's our fault, not at the moment anyway. So let's go ahead and change the pre-regulator TL594 and see whether that helps us at all. So this time I decided to use a different technique. Got myself a little tool. I just wanted to try this really crappy desoldering iron. It's mains powered, cost about £7 in Farnell. I thought I'd give it a shot. There's nothing to lose. £7. It's like your usual solder sucker. You press it down, press the button, and it sucks the solder. But it has a heated tip, which is brilliant. So you can really get the proper vacuum on it. So let's try it out. The trick is really to hold it flat and to make sure that your heated part of the tip is always touching the solder. And that seems to work pretty well, actually. I'm quite impressed. That's quite a nice vacuum there. Really nice. I applied a little bit more solder, fresh solder, on every joint before I started doing this. Just get rid of some solder from the inside, just to make sure that it melts quicker. Okay. That seems to have worked pretty well. Just get my iron and just touch the ones that they're all bent, so I'm just going to straighten them all up with my iron. But it worked. Wow, I'm really impressed. For £7, one of those mains powered irons, which I hate, and this one is really good. Let's see, let's flip it. Let's have a look at it. Don't want to put too much force on it, because that can pull your pads up. One side is loose. Excuse my hand, I know you can't see anything. You can try and loosen up the other side gently. Let's have a pull. There you go. Alright, look at that. No lifted pads. The chip came out nicely. Beautiful. So we've got our TL594 brand new, and hopefully that's going to do it. The new chip is in. Moment of truth. Turning on now. And let's check the 38 volt rail. And still 40.5, so that was not the problem. Awesome. Okay, so I'm gonna now swap back the LM358, and I'm gonna swap the other one, the other TL494 from the previous repair. I'm gonna swap it for TL594. So that way we have all new chips, and there's no doubt. And then we can go and check the other bits. Right, so I swapped the LM358. As David suggested, I've actually installed a IC socket there and pushed the 358 into it, just in case I need to swap it again. So that's a brand new chip. I'm going to turn it on and measure the voltage. So we'll check the 38 volt rail. Oh, and the voltage has dropped, 35.5. Let's see if we can adjust it. So we adjust the minus 8.6 rail. Awesome, look at that, minus 8.45. Well, it's good enough. My OCD won't let me leave it there. Now that I got it working. Right, minus 8.61. Let's check the other rails. So minus 5.2, minus 5.13, good enough. That's a bit high. 5.4. Minus 8.6, we just set it, so that's perfect. 8.6. 8.7, it's a bit higher. 38 volt rail. 37.4. And 100 volts, well, 97.6. I will actually adjust it slightly. 5.4 is a bit high. Let's see if we can bring it down a bit to find a happy medium. Say 5.3 on that one. Minus 8.4. Let's see what the specification actually says in the service manual. In the service manual we can see the limit for the adjustment of the voltages. So you can see roughly plus minus 0.15 on the 5 volt rails. On a minus 8.6 rail, well, you go pretty much spot on that one, and the other ones should be well within. Let's see if we can do that. Right, minus 8.6. So minus 5.2 is minus 5.13. That is well within spec. Plus 5.2. That seems to be just a bit out, but I think that might be tolerable. Yeah, anyway, let's have a look. The rest of the voltages, plus 8.6, plus 8.73, that's within spec. 38 volts, 37.43, that's within spec. 100 volts, 97.5, that's within spec. So we're well within spec. This, okay, I won't worry about this. 5.4, it's only 60 millivolts above the spec, so yeah, I'll leave it there, I guess. It may well be just because the storage board is not installed, there's no load on it, so it's slightly higher than it should be. I believe as soon as I install the storage board it will drop. So let's have a look on the actual screen. Right, so we've got our sine wave going in, beam find, there you go, position up or down, doesn't do much. The horizontal just doesn't do anything. Yep, so the horizontal is faulty, which is a shame. It seems to have worked before. Let's see channel 2. AC coupled, there you go. Now, so we got some more troubleshooting to do. Brilliant. Okay, so I call it a success. It was faulty LM358. It was my fault. I thought that the other op amp would work okay in there, and it obviously didn't. It may have been faulty as well, I'm not sure. But after swapping the op amp, it seems to work. So the power supply is fixed. The rail voltages are good. They're all within spec. Reasonably within spec, apart from the 5.2, but that's only a little bit out, so that's tolerable. And I'm sure when I put the storage board in, it's going to change slightly downwards. So in the next video I'm going to have a look at the fault that the oscilloscope itself doesn't work anymore, and see what is blown up. My suspicion is the horizontal board or the horizontal circuit, but I'm not sure. This is my first oscilloscope repair. I've never done an oscilloscope repair before, so thanks for sticking with me. I'll have a read through the service manual, and I hope to see you next time. If you enjoyed the video, if you liked it, or if you found any value, please click on the thumbs up button. You can also subscribe, and that would be awesome. You know, if I publish a video, you get a notification. So you can subscribe up here or down there. I'll put some information on the datasheet, and I'll stick the service manual in the notes as well. I'll hope to see you next time. So in the next video we'll do some more troubleshooting. Take care.